Recently, Lenovo launched a brand new high-power GaN charger, which is Yoga CC130, the same series as Yoga Computer. Its dual USB-C port maximum output can reach 130 watts, even beyond 100 watts, which is very impressive. Okay, let's unbox it firstly. The packaging is quite simple. Let's look at the specification on the back. It supports maximum of 130 watts output with any port, because it will intelligently distribute the power. The model is Yoga 130GL. The maximum output of a single port is 100 watts. The total output of dual ports is up to 130 watts. PPS mode supports maximum of 3 amp 45 watts. The production date for this one is May 2021, close to today. Now let's see the inside of the box. The box is tightly sealed. Open it slowly. There are only one charger and a manual. Just like Anchor 45 watts, no cable. Tear off the plastic film on the outside of the charger. The black shell is very smooth and bright. The edge is also very smooth and round. The texture is great when you hold it, but it's easy to be stained with fingerprints and oil. At the same time, it's easy to leave scratch. The charger adopts 14 pins. The specifications on the bottom are the same as those printed on the package. Next, let's measure the size and weight. The measurements are 71, 71, and 30 mm, and the weight is 256 grams. Compared with Apple 96 watts charger, it will be smaller, obviously. Use ChargerLAB PowerZ KT002 to test the protocol of 2 USB-C. It supports Apple 2.4a, Samsung 5V 2A DCB protocol, and 5 fixed PDOs: 5V 3A, 9V 3A, 12V 3A, 15V 3A, 20V 5A, 1PPS mode 3.3 to 16 volts 5 amp. 2 USB-C are the same. When you charge two devices at the same time, you can see that one of the USB-C can reach 100 watts and the other one is up to 30 watts, which is 130 watts totally. But there's one thing we need to know, that's PPS mode. Maybe you will notice that we just tested the PPS mode is 3.3 to 16 volts 5 amp. Which is different from what's printed on the box, 3 amp. After our multiple retests, actually it can support 5 amp under PPS mode. Now start to tear it down. Okay, it's done. Remove the AC pin firstly. Since the module can't be pulled out with pliers, there's one solution: cutting machine. Cut along all sides. Okay, successfully removed the inside PCB module. 2 pieces of pure copper heatsink are wrapped outside. There is a layer of thermal isolation plate and a layer of thermal pad under the heatsink. It needs to be cleaned up as well. On the top is a Z-shaped board supported and fixed by a plastic column between it and the motherboard. This is the PFC boost inductor. 2 SMD rectifier bridges for input rectification and heat dissipation are behind it. The premier filter capacitor is in the middle. There is a ground wire outside the transformer. A lot of glue is filled around the internal components to fix and dissipate heat. There is an isolation plate between the primary and secondary circuits for insulation and isolation. The USB-C port is welded vertically through two small boards. Continue to tear it down, and then the components of this PCB have just been removed. This is where the transformer is located with a lot of glue. The PFC boost circuit is on the back. This is ON Semiconductor PFC boost controller. Here are two Navitas GaN power ICs NV6117, which is the PFC boost switch tube. The corresponding area on the front is PFC boost inductor. Here are two Vishay tantalum capacitors for filtering, used to power the master control chip and PFC boost controller. This is ON Semiconductor's LLC controller, and two Navitas GaN power ICs NV6115. Here is an optocoupler across the primary and secondary circuit. There are 4 IC electrolytic capacitors for high voltage filtering in the middle, which is 450 volts, 22 microfarad. Here is a fuse. This is a resonant capacitor. Let's look at another small board. Firstly, this is a safety capacitor. A common mode choke is behind it. There are also 2 film capacitors. Here is a filter inductor wrapped by a circle of insulating tape. 2 SMD rectifier bridges are on the back, which can reduce thickness. After reviewing the switching power supply, let's look at the output part. Its synchronous rectifier circuit is on the back. Here is a transformer. The LLC synchronous rectifier is on the back, composed of 2 synchronous rectifier controllers and 2 synchronous rectifier tubes, all from ON Semiconductor. The 2 solid filter capacitors in here are from PoiCap RT series, which are 25 volts, 560 microfarad. It also has ultra-high ripple current resistance capability. A filter inductor is next to it, which is protected by outer heat shrinkable tube. The USB-C ports are welded vertically on 2 small boards. SMD solid capacitors are used for secondary step-down output filtering. The step-down inductor is next to it. The receptacle ports are welded in the whole of PCB. The 2 small boards are the same. We can look at one board. Firstly, this is an MPS synchronous buck converter for buck output. The USB-C step-down protocol chip is in the middle. Well-trained WT6633P. It supports USB PD3 and gets the USB-IF Qualcomm QC5 certification. On the other side, there are 2 moist tube and a buck inductor. A solid capacitor for step-down output filtering is behind. There is a moist tube. Okay, that's all for today's teardown. I also noticed this charger is manufactured by Lecture Precision, which is the same factory as the AirPods series, so its quality ought to be excellent. Our channel is still in growth, so if you want to see more content like this and haven't subscribed to us, you can click the subscribe button or visit our website ChargerLAB.com. I'll see you the next time.